In this unit, we're going to focus on solving equations. In this lesson, we're going to be solving word problems.
Okay. Hi, everybody. In this lesson, we're going to be looking at solving word problems. Okay. It's just to give you a little bit of some tools to think about as you're moving forward and starting to solve word problems here. So we know that this can be a little bit of a problem here for some people here. And so let's try to identify what the issues are. Okay. So why do students struggle with word problems? Well, there's a few good reasons why that happens here. First of all, a lot of people struggle because they don't read the question. Okay, they don't read the question fully. So what that really means is they don't actually understand what it is they're being asked for. They skimmed over it really quickly. They were trying to look for certain things because they thought they understood what was going on. They're trying to get rid of the extraneous information because oftentimes there is some extra information in there that you don't really need that you got to weed through, but they're too quick to do it. They don't really read fully. Uh, Another situation is where they haven't really developed the appropriate skills. Okay, it might be that at this point here that you're struggling with a word problem because you don't actually have a good developed set of skills to handle the math that's being presented in the word problem. Okay, and that can be problematic. Okay, for sure. Um, Sometimes it's just misunderstanding. Okay, sometimes it's just misunderstanding the question here, um, and sometimes answering a question that wasn't actually asked. You kind of read through it and you answered the question that you thought you read. And that actually has to go with reading the question fully and carefully. Basically, we want you to read not only fully but read carefully. Okay, and sometimes it's about missing units. Okay, or rounding. Sometimes this is what causes the problems. Sometimes people round too early in the problem, and that little bit of rounding creates just a little bit of an error in the answer. And after you do a bunch of work with it, that little error gets larger and larger and larger. So you got to be careful about that too. So, what are some strategies? What are things that can help you with this? Well, first of all, as you're reading through, maybe highlight information. Okay, highlight things that jump out at you as important. Okay, like the numbers. One of the things you might want to do is as you're going through that, summarize what you've read. Okay, what is this sentence telling me? What is this next sentence telling me? Is this information important or is it irrelevant? Kind of ask yourself those questions here. If you have to, reread it. Make sure you understand it. Circle. Okay, like circle the numbers. Whoops. Now, by the way, not all of the numbers given in a problem are always going to be uh, pertinent to the problem. So you got to be careful that you're circling numbers that are giving you information here. So, for example, if we're talking about I don't know somebody's birthday party, and we're talking about how they're going to divvy up all the like let's say vanilla and chocolate cupcakes here, then it doesn't really matter what the date is. Okay, so if they include the date, well, that's not helpful. It's just extra information that's not important. Another thing that you can do here to help yourself out is verify your answer. Okay, sometimes people get answers that couldn't possibly work. When I teach, there's a there's this one topic that I go over, and on the calculator, I show students how to answer the question on the calculator, but I always purposely leave out a set of parentheses to see if people are reading it carefully here. And then when we get an answer, the answer is like the distance that two people are standing away from each other is like 10 times the circumference of the earth. It's just a ridiculously large answer. And so, but I'm looking to see if people are catching that there's an error, that answer doesn't make any sense, right? So verify your answer. Does it make sense? Okay. And then finally, it always helps to do this, to answer the question, okay, with a sentence. Oftentimes, teachers are going to require that you do that. Now, one of the reasons why we do this is to make sure that you actually answer the question. Okay. Frequently, I've watched students that will get an answer that they'll do a bunch of work, a bunch of algebra related to a word problem. They'll put an answer down, but they didn't actually answer the question. Okay, so you had to go back and answer the question. If you make it a habit of answering the question with a sentence, then you're far less likely to have not answered the question. Okay, or even the appropriate question. Sometimes people, like I was saying before, they answer a question that really wasn't asked. It's just something that they read here, so or they read into the problem, but they didn't actually read the problem. So just be careful with that. Now let's take a quick look here. What are some words that are synonymous with the following? So we want to look at some things here that maybe give you a little bit of a clue, okay, as to how to go about like putting the equations together. What are some word clues that can tell you that you're supposed to do for addition, for example? And what you might read are the words sum, total. They might even just simply say add or increase, or even the word more. Now, compare that with subtraction. In subtraction, you might see decrease. Okay, difference. Okay, that's a common one. What's the difference between two values? Or less. Okay, they might even just flat out say subtract. Okay, words that identify multiplication. Product. Product means multiplication. You might see them say times. They might say multiply. Or they might say stuff like doubled or tripled. Okay, and in some cases, if you're working with percentages, okay, if you're working with the percentages, you might actually see the word of. And the word of in that case also implies multiplication. So like 50% of something, I'm going to take that 50%, put it as a decimal 0.5, and then multiply it by that number here. Anyway, something to consider there. Quotient for division. Split. If we're going to split things into groups of a certain size, that the word split is going to mean division here. They might use the word divided by, or half, or quarter. Words like that. If I want to apply equality, we might say that two things are the same. Okay. Although we use the word total over here for sum, sometimes you'll see the word total, and when you read the sentence in the word problem, it'll be like for a total of, and they'll give you a number here, and that typically means equal to that value there. Sometimes the word is, and when you want something like this, really can't think of too many places where we wouldn't just tell you use the word squared there. Okay, but anyway, having this, like it says, you're having this vocabulary. It's just going to make things a little bit easier when you're trying to create the models. Okay, the mathematical models represented the relationships in the word problem that you're reading. Anyway, let's have a look at some problems together. Some kind of preliminary problems with this, and then we'll keep moving through the material. Okay, so the question here says, let's translate the word sentences into math sentences or into equations here if we can. Sometimes they don't go into equations. Okay, whoops. Sometimes the information that we're given isn't actually a complete equation, so that doesn't always hold true right there, but we'll see what happens here. So the sum of a number and 10. Okay, sum, so is going to mean addition of a number. Well, I didn't tell you what it is. Let's just pick a variable, usually x, and 10. That's it. That's the best I can do to represent that. Maria's age 6 years from now. Okay, so 6 years from now, we're going to add 6 years to that. So I don't know what Maria's age is. Let's call it x. We're going to add 6 to that. The product of, okay, here we go. Product means we're going to multiply something together of 6 and a number. So 6 and a number are going to be multiplied together, is added to 4. Okay, is added to 4. So 6 times x plus 4. 3 less than a number. Now, I'm going to show you right now. One of the things that people frequently do wrong with this one is they'll say 3 less, so 3 less than a number. That is not true. This is not true here. 3 minus x would be 3 less a number. It's that word than that makes all the difference here in this particular problem here. When I say less than a number, okay, I'm starting with x. We are starting with x here, and this is going to be x less 3. So I want to find something that is 3 less than x. Okay. If, for example, if I am younger than you, like you're older than me, okay? If I am 3 years younger than you, I have to take your age and subtract 3 from it to get my age. That's what's going on there. Okay. But when I just say less 3 less a number, that means 3 subtract a number, and that would be the other way around here. I hope that makes sense. That's because of the way subtraction works. Sometimes we express it like verbally somewhat backwards to the way you would normally write it. Half of a number is added to 12. Okay, so half of a number of, there we go, there's that multiplication thing. So half of a number is added to 12. Okay. This next one here, twice the sum of a number and 8. Twice the sum of a number and 8. So, okay, 2 times. But it sounds like what we're going to do here is take the twice the result that I get. So this is sort of implying that there's a set of brackets here, x plus 8, and then I'm going to take twice that. Twice the sum of a number and 8. Okay, so x plus 8, put that in brackets to make sure that happens first, and then multiply by 2. Now here, a number is decreased by, okay, number is decreased by 2/3 of itself. There's that of again. So 2/3 of itself. Well, again, add number, that was x here. So of itself, that's going to be x again. So this is going to be x minus 2/3 multiplied by x. And Jean's age in a decade. Okay, so when we say in a decade, basically that means like 10 years from now. So we're going to take Jean's age right now, we're going to leave that as x, and we will add 10 to that. Okay. Now I went through that relatively quickly. That does not necessarily mean that these are super easy. Okay. In fact, it's quite common to have people struggle to kind of get their heads wrapped around how that works. So don't feel bad if you are having some issues here. Now we're going to try taking a look at an equation here. Okay, given in a word sentence. So the sum of a number and 12 is 100. So it's that word is that is going to be implying the equality here. So the sum of a number, that's x. The sum of a number and the sum of a number and 12 is 100. Okay, that's how that works here. So now what I want you to do is try these next couple. Maybe pause the video here and take a quick look at those. Whereas I'm just going to jump right in. So 5 more than 2 times a number. Okay, so 5 more than 2 times a number. Okay, 2 multiplied by a number here. Okay, now you might just get used to the fact that the word than sort of implies a flip to the things here. So another way you could write this is 2x plus 5 here. Now, it doesn't really matter with addition because order does not matter with addition. Okay? With subtraction, it does. Subtraction does. So when we were working on that previous question, it did matter that I flipped those things around here. 3 times the sum of a number and 8. Okay, so 3 multiplied by the sum of a number and 8. There we go. And so this is 3 times x plus 8. Okay, so now let's just go through and start working through some problems here. So now that we've spent some time on solving equations and translating word sentences to number sentences. Now we're going to look at how we solve them, and hopefully you can pick up some of the techniques, okay, for solving, and you'll see us going back and pulling out different things that we've done over the last few lessons here. So take a look at this one. 9 more than a number. Okay, so 9 more than a number, I don't know what that is 33. We want to find that number. So, well, once we've got the equation down, we can go back to the skills that we've developed over the last little while to solve that equation. So, for example, I've got a binomial on the left-hand side. What I need to do is remove the constant. So I'm going to get x is equal to 24, and that's the number. Okay, the number is 24. Now, I don't need to go any further than that. I don't need to do anything else here because the x was isolated as soon as I did that. Okay, that's what I was looking for. Let's take a look at this next one here. Okay, this question says 8 less than 7 times a number. Okay, remember that then is switching the order. So 8 less, I'm going to subtract 8 from 7 times a number. So that's going to be 7 times x. So minus 8, there we go, is the same as, that's equal to 4 more than, okay, here we go, 4 more than, we're going to add 4 to something, but we're going to switch the order here, 3 times the number. Okay, so we're going to find the number. So there we go. So it took us a little bit to get that. And remember, every time we've got this and number here, that and number is referring to an unknown. So we're going to use the letter x to refer to that. So the first thing I'm going to do is I'm going to move my x terms over to the same side here, okay, to combine them. So we're going to subtract 3x from the right-hand side to bring that over. That's going to get me 4x minus 8 is going to equal 4. And then I'm going to bring the 8 over by addition, and I will get 4x is equal to 12. And then finally, I'm going to divide both sides by 4 to get x is equal to 3. So the number is 3. Okay, so now we're going to take a look at some problems where there's more than one unknown. Okay, that adds just a little bit of a layer of extra difficulty to it, but it's not actually all that bad. We're going to take a look at a couple problems here, and hopefully you'll see what we mean by that. So first of all, let's start off with this. What does the word, sorry about that. What does the word consecutive mean? Okay, well, they're referring to numbers, okay, that follow each other immediately, okay? So for example, 4 and 5 are 2 consecutive numbers here, okay? Now, there is a little bit of that can be done with this, because I could say, for example, if I said consecutive evens, then for example, it might be 4 and 6, because 5 is not an even number, but 4 and 6, they follow immediately from each other as even numbers here. Now, one way to look at this in terms of like algebra here, well, what if I didn't know that the number started at 4? What if I just knew it was like, well, it's x? Well, the next consecutive, like the next number, if I'm just talking about specifically just consecutive numbers, well, that 5 is the same as 4 plus 1, or that unknown plus 1. But if I was talking about evens and I didn't know where we started, well, the first number would be x. The second one would be x plus 2 instead. Okay, and I could do a similar sort of thing with odd numbers. But anyway, the whole idea is that these are numbers that follow each other in some sequence, in some pattern there. And they come right after each other. So a problem to solve. Here we go. The sum of 2 consecutive numbers is 23. Okay, the sum of 2 consecutive numbers. Now I'm going to introduce for myself here a let statement. Okay, so what I'm going to do is I'm going to start to give myself just a little bit of extra help with this. I'm going to let x be the first number. And I'm going to be right up front with what I'm doing here. X is the first number. Now, that means if I'm talking about two consecutive numbers, that x plus 1 is the second number. Okay, so once I've established that, x plus, this is the sum of two consecutive numbers, x plus 1 is 23. Now, the question is, what are the two numbers here? Well, that means I have to figure out what x is and then what x plus 1 is. But to start off with, I've got this equation that I got to solve. So when I add those together, I'm going to drop those parentheses here. That's going to give me 2x plus 1 is equal to 23. And actually, based on the pattern that I've set before, I should have done that in black there, is equal to 23. So I'm going to rewrite this up here. 2x plus 1 is equal to 23. Now, first thing I do is bring that 1 over to get 2x is equal to 22. And then we divide both sides here by 2 to get x is equal to 11. Now, that means the first number is, whoops, oh, sorry, I'll clean that up there. The first number is 11. Okay, the second number is, now what I got to do here is just come back over here, is going to be the x plus 1, the unknown plus 1. Well, the second number is therefore 12. And there we go. The next question here says the second of two numbers is 7 times the first. The second of two numbers is 7 times the first. Okay, so we're going to let x be the first number. And the second number, okay, we're going to let the second number is 7 times the first. So 7x is the second number. Now, all that is just basically me pulling information out of the first sentence here. Their sum is 32. Okay, so x plus 7x is equal to 32. We're going to determine the two numbers. Okay, well, first thing I'm going to do is I'm going to add those two together. I've got x, 1x, and 7x, okay, for a total of 8x is going to be equal to 32. And then I'm going to divide both sides there by 8, and we will get that x is equal to 4. So here we know that the first number is 4, okay, because the first number was x, and the second number is, okay, well, the second number is going to be 7 times that, so 7 times 4 is going to be 28. So the second number is 28. Okay, now we're going to take a look at problems that involve coins and money. And one of the things that you want to be able to do here is we're going to convert these things into decimals, right? Because basically we want to figure out these things, figure out what we're looking at here in terms, whoops, man, I keep doing that, in terms of a dollar. So a penny is going to be 100th of a dollar. A nickel, oops, no. See, I wrote a comma there. I didn't want a comma. A nickel is 5/100ths of a dollar. A dime is 1/10th of a dollar. A quarter is 25/100ths of a dollar. A loonie is $1, and a toonie is $2. So using those represent ways of representing those units of currency here, and it enables us to do the math on these things here. So here we go. A laundromat accepts quarters and loonies. There are an equal number of quarters and loonies totaling $11.25. So how many of each coin are there? We'll say, so we're going to let x be the number of each coin. Okay, because it turns out they're the same amount here. So there are an equal number of quarters and loonies. So, okay, so for example, the quarter is going to be 25 cents, and we've got X of them. And then the loonie is $1, and we've got X of those. And we're adding them together because we've got a total value of equal to $11.25. Okay, so now how do I solve that? Well, first of all, notice I've got like terms on the left-hand side here. So I'm going to add those together. 1.25x is equal to 11.25. And now what I'm going to do is I'm going to divide both sides by that coefficient. And we're going to get here that x is equal to 9. Now, something that we haven't really done yet, that's because the equations have been relatively straightforward here, is we haven't really done a verify here. So let's just take a quick look and verify this. Okay, so over here, let's take a look at a verify. So we're going to verify that x is equal to 9. So what we do here is we take a look at our equation here, and we're going to plug 9 in. So 0.259 plus 1 times 9, does that equal $11.25? In other words, I'm not 100% sure about that equality here. Okay, well, 9 times 0.25 is going to get us 2.25, and 9 times 1 is just 9. Is that the same as 11.25? And yeah, actually it is. When you add those together, I didn't know if they were the same, but it turns out they are the same. Okay? So, how many of each coin is there? There are 9 quarters and 9 loonies. Good. Let's take a look at one more problem here. Okay. I have 15 more dimes than nickels. If I have $2.55 in total, how many nickels do I have? Okay, I have 15 more dimes than nickels. So let's do this. Let's let x be the number of nickels. Okay, because if x is the number of nickels, then that means x plus 15 is the number of dimes. It's easy enough to set that up here because I can read that in the problem. I have 15 more dimes than nickels. So whatever the number of nickels is, x plus 15 is going to be the number of dimes. So now I know that I'm going to have 0.05. There's my nickel. X, okay? So x of them. Plus, now I got to put this in parentheses here because this is the number of dimes that I've got. And the value of the dime is going to be that 0.10, that 0.10. And that is supposed to be $2.55 when I add that all up here. So here we go, 0.05x plus I'm going to distribute that 0.1 to both of those, and that's going to be 0.1x plus 1.5 is equal to 2.55. Now I'm going to add together those like terms, and I'm going to get 0.15x plus 1.5 is equal to 2.55. And now this is an equation just like we solved many times before. We're going to subtract the 1.5 from both sides, and that's going to get me 0.15x is equal to 1.05. And I'll maybe rewrite that up here. 0.15x is equal to 1.05. And now I'm going to divide by 0.15 to get the x by itself, and we get that x is equal to 7. So how many nickels do I have? Well, okay, so the way I set this up here is I let x be the number of nickels. So this means that I have 7 nickels. Okay, now let's figure this out though. Let's just verify this real quick. We're going to throw this off to the side. We're going to verify. Okay, so if that's true, that should be 0.05 times 7 plus 7 plus 15 times 0.10. Does that equal 2.55? Okay. Well, when I multiply that together, the first two values, 0.05 and 7, I get 0.35. And then here, I've got 12. Okay, I've got 12 times 0.1. So it's going to be 1.2. Okay, because remember, this is going to be 12 multiplied by 0.1 is going to be 1.2. Does that equal 2.55? Now, I'm just going to do this really quickly here. This something looks a little bit odd to me. No, I get 1.55. So what did I do wrong there? We have got a... Oh, one, because I'm sorry, because it's 15. Ugh, that's why. As soon as I did that, something was not working out here. But yeah, it's because I have the wrong number here. This is 7 plus 15. So that is going to be 2.2. Yeah, instead of 1.2, it's going to be 2.2. And so, yes, that does, in fact, get us 2.55 equals 2.55. So that did work. It does verify that, in fact, when I say I have 7 nickels, that is correct.